Saying is one thing, but proving is another. Hello and good day to everyone. This is BSc 1B Group 3 presenting to you counter examples. According to Khan Academy, showing that a mathematical statement is true requires formal proof. However, showing that a mathematical statement is false only requires finding one example where the statement is not true. Such an example is called a counterexample because it's an example that counters or goes against the statement's conclusion. In other words, a counterexample disproves a universal statement. It makes us think, analyze, and find a gap in the information to prove that it is false. Obtaining counterexamples is a significant part of mathematics because doing math requires us to develop critical attitude towards claims. Additionally, it can also be applied in our daily lives. For example, may nagsabi sa'yo na ang lahat ng pusa ay mabalahibo. Maniniwala ka ba agad? Siyempre, hindi. Mag-research ka muna at malalaman mong may lahi ng pusa na hindi mabalahibo. So, ang statement na ang lahat ng pusa ay mabalahibo ay ating na-disprove sa pamamagitan ng paghahanap ng example na nagpapatunay na mali ito. At yun ay isang halimbawa ng counterexample. Heto pa, kung sasabihin ka ng tao na mahal ka niya, maniniwala ka ba agad? Siyempre hindi. Suriin mo muna kung totoo ba o hindi. Kaya nga sa relationship may ligawan stage eh. Paano kung dalawa kayo? Paano kung pinagsasabay-sabay kayo? Kaya, when you have an idea or when someone tells you something, you have to test that idea by trying examples. And here are key notes to remember. 1. A single example cannot prove a universal statement unless the universe consists of only one case. Number 2. A single counterexample can disprove a universal statement. The following are more examples for you to better understand counterexamples.
Here's the first example. Verify that the statement is a false statement by finding a counterexample. We have here 2 over x is equal to 2. To find a counterexample, we need to find a number that would make the statement false. Now, let x be equal to 2. Simplifying 2 over x, the quotient is 1. Thus, 2 over x is not equal to 2. Parang kayo ng crush mo. Crush mo nga siya, pero crush ka ba? Here's another statement. 2x squared is equal to 2x over x squared. In this statement, let x be equal to 2. Now, the statement will be 2 times 2 squared equals 2 times 2 over 2 squared. To further simplify this equation, we have 2 times 4 equals 4 over 4. To get the final answer or equation, we have 8 equals to 1. As we can see, the statement is now proven as a false statement. This example can be compared to love or associated with love. Yes, they may give you sweet words like I love you, I miss you, and etc. But do their actions actually match with their words? Think again.
And here is another example for you to better understand this topic. If n is an integer and n squared is divisible by 8, then n is divisible by 8. So, we have to find a number that would make the statement false. So we have to let n is equal to 12 and n squared could be 144, so this is divisible by 8. Then, we're going to let n is equal to 12 and n squared is divisible by 8, then n is divisible by 8. So, n is equal to 12 is not divisible by 8. So in this case, we have a counterexample that let n is equal to 12 and 12 is not divisible by 8. If we apply this to our everyday situations, It is just like the one that no matter how you demonstrate that you are correct, someone will always find a way and prove that you are wrong.
Here's another example. The square of an integer is always an even number. Which of the following number provides the counterexample showing that the statement above is false? A, -4, B, -2, C, 6, D, 1. In letter A, the number is -4, and we will find its square. -4 squared is equal to 16. That's why letter A is not the counterexample of the statement above because its square is an even number, which is 16. In letter B, the number is -2, and its square is -2 squared is equals to 4. That's why the letter B is not a counterexample of the statement above because its square is also an even number. In letter C, the number is 6, and the square of 6 is 36. And in this choice, letter C is also not the counterexample of the statement because 36 is also an even number. And in letter D, the number is 1, which is the square is 1 squared is equal to 1. So the square of 1 is 1, which is an odd number. That's why the letter D is the counterexample that shows the statement the square of an integer is always an even number is false.
Now, for another example, we have quantity a plus b squared is equals to a squared plus b squared. Same process, we're gonna find just one statement that will make the whole statement a false statement. Now we're gonna let a equals to 1 and b equals to 2. If a is equals to 1, then quantity a plus b squared is equals to 9, and if b is equals to 2, 1 plus 2 then squared, then it will be 9 because 1 plus 2 equals 3 and 3 squared is equals to 9. Then if a is equals to 1 and b is equals to 2, a squared is equals to 1 because 1 squared is 1, and b squared will be 4 because 2 squared is equals to 4, and 1 plus 4 is equals to 5. Then 9 is not equals to 5 because quantity a plus b squared is equals to 9, and a squared plus b squared is equals to 5. So we can conclude that quantity a plus b squared equals to a squared plus b squared is not true at all because we found an counterexample to make the equation a false statement. Thank you.
To summarize, a counterexample is a special kind of example that disproves a statement or proposition. Counterexamples are often used in math to prove the limits and boundaries of conceivable theorems. A theorem is a rule that can be expressed symbolically or mathematically in algebra, geometry, and other areas of mathematics. Writing a counterexample requires finding a specific case when a statement is wrong and showing how the case disproves the statement. To find a counterexample to a conditional statement, you need an example to make the initial condition true, but at the same time make the concluded statement false. Counterexamples are helpful because they make it easier for people to prove the validity of particular conjectures or ideas. As a result, mathematicians can save time and concentrate their efforts on developing concepts that will lead to provable theorems. Counterexamples are incredibly important for logic, which is, in turn, important because it provides the foundation for almost all mathematics.
Thank you guys for listening. We hope that you've learned something from our video tutorial. Bye!